Good day, sir. I am Chef Iver or Refrea from the course ECE 20L-2, Section A4. And furthermore, my two groupmates are Aldryn Madronero and Joshua Cruz. And today, I will be discussing our project entitled DC Power Supply with Multiple Outputs in Partial Fulfillment with the course. Before we start, let us first gloss over the contents of this video. First, I would like to mention the essential information which was provided to us prior to the start of the video. So our group number is 5 and the assigned voltages to our group are the following: 0 volts, 5 volts, 8 volts, 18 volts, and lastly 25 volts respectively. In addition, this video will feature the following sections: the definition of a DC supply, what is a transformer and how does it work, the various components necessary for the simulation, the image of our circuit, and etc. So, first we will have a brief introduction. So, this is the title, the DC power supply. So, what is a DC power supply? The DC power supply converts standard 220 volt, 60 hertz AC available at wall outlets into a constant DC voltage. The DC voltage produced by a power supply is used to power all types of electronic circuits such as televisions, stereo systems, DVD players, and laboratory equipments. And a brief introduction. The availability of electricity is a vital aspect of several items for electronic equipment. While some battery-driven, others need large power supplies. The power supply is necessary for the efficient operation of all the equipment through the circuitry and design. Circuits may be separated into a set of elements or building blocks. Everything is sufficient to operate the power supply as a whole, but for the efficient running of the whole system, every part of the power supply system is needed for a satisfactory output. In addition, DC power supplies are power supplies which produce an output DC voltage. Power supplies are devices that deliver electric power to one or several loads. They generate the output power by converting an input signal into an output signal, in this case, a DC output. So, we will now go to the transformer. So, what is a transformer? A transformer is an electrical apparatus designed to convert alternating current from one voltage to another. It can be designed to step up or step down voltages and works on the magnetic induction principle. A transformer has no moving parts and is a completely static solid-state device, which ensures under normal operating condition a long and trouble-free life. It consists in its simplest form of two or more coils of insulated wire wound on a laminated steel core, as stated in the image. Next. So, how does a transformer work? When voltage is introduced to one coil, called the primary, it magnetizes the iron core. A voltage is then induced in the other coil, called the output secondary or output coil. The change of voltage or voltage ratio between the primary and secondary depends on the turns ratio of two coils. So, voltage regulation next. On the side note, we are discussing about the necessary equipment or parts of our simulation. So, going back, what is a voltage regulator? A voltage regulator is an integrated circuit IC that provides a constant fixed output voltage regardless of a change in the load or input voltage. It can do this many ways depending on the topology of the circuit within, but for the purpose of keeping this project basic, we'll mainly focus on the linear regulator. Next. So, rectifier. So, a rectifier is an electrical device that converts alternating current AC, which periodically reverses direction, to direct current DC, which flows in only one direction. This process is known as rectification since it straightens the direction of the current. So in our simulation, the type of rectifier is called the bridge type rectifier. So what is a bridge type rectifier? The rectifier efficiency of a bridge rectifier is almost equal to the center tap full wave rectifier. The only advantage of bridge rectifier over center tap full wave rectifier is is the reduction in cost. In addition, in bridge rectifier, instead of using the center tap transformer, 4 diodes are used. In addition, a bridge rectifier is a type of full wave rectifier which uses 4 or more diodes in a bridge circuit configuration to efficiently convert the alternating current AC into direct current DC. So here is the bridge type rectifier that I had discussed. Next, the current limiting resistor. What is the current limiting resistor? A current resistor regulates the current in a circuit and reduces the power. It helps to assess the value of the resistance to be applied to a light emitting diode, LED, such that the LED transfers the current. The measured energy usage is also defined by the LED. Next, the filter capacitor. The filter capacitor, a capacitor originally known as a condenser, is a passive two-terminal electrical component used to store energy electrostatically in an electric field. The capacitor is a component which has the ability or capacity to store energy in the form of an electrical charge, producing a potential difference static voltage across its plates, much like a smaller chargeable battery. Next, a load. A load is an electrical charge. Electrical is an electrical element of a circuit using active electrical power. This is opposed to a source of electricity like a battery or power generator. Examples of loads include are the devices and lamps in electric power circuits. Next is the rotary switch. The rotary switch moves in a circle and can stop in several positions. They are used to control many different circuits within a single switch. Rotary switches can also be designed to have many contacts happening at once on a single switch position. While rotary switches can be found on many types of industrial equipment, they can also be found in consumer equipment such as in a car for adjusting things like the speed of the fan. Next is the oscilloscope. The main purpose of this device is to graph an electrical signal as it varies over time. Most scopes produce a two-dimensional graph with time on the x-axis and voltage on the y-axis. And the multimeter, A multimeter or a multitester, also known as a volt/ohm meter or vohm, is an electrical measuring instrument that combines several measurement functions in one unit. A typical multimeter may include the features such as the ability to measure voltage, current, and resistance. Next, the rectifier diode. The 4 diodes were used in rectifiers. This is also known as rectifier diodes. It is used in power supplies to transform AC to DC, and the rectification phase is also done. They're often found in other circuits where the diode must be passed by a broad current. The Zener diode. In its reverse bias mode, the Zener diode is used and serves as a voltage regulator. The voltage regulator's job is to generate the preset output voltage, which remains constant independently of changes in input voltage or load conditions. And this is the simulation of our circuit, as you can see. So I will now be discussing the simulation of our circuit. So this is the discussion part. The project is about DC power supply with multiple outputs. We conducted a simulation with the use of an application called multisim. We choose the multisim because it is a more user-friendly, and the circuit that we created is based on the example circuit of our professor during his lectures. A DC power supply provides a constant voltage to all loads in a circuit. We started the circuit by placing an AC power source with a standard 220 volts and 60 hertz. A step-down transformer with a ratio of 5:1 was also used to reduce the voltage output of the circuit. In addition, a full-wave bridge type rectifier is used and a capacitor for the filter was also placed. And lastly, Zener diodes were used to regulate the voltage output of our circuit. It is important to choose the right models to achieve the given values as close as possible. And in addition, so in conclusion, the objective of this project is to build and design a basic DC power supply with multiple outputs and to produce the assigned values of voltages which were 0 volts, 5 volts, 8 volts, 18 volts, and 25 volts. A software called Multisim was used in creating the simulation, and the circuit as well as the software was more user-friendly than other simulation softwares. In this project, we learned to create a basic DC power supply that produces a constant voltage to all loads. With the right Zener diode models, we were able to obtain the values of 0 volts, 5 volts or approximately 5.009 volts, 8 volts or approximately 8.118 volts, 17.931 volts, which is approximately 18 volts, and 24.949 volts, which is approximately 25 volts. To sum it up, we were able to accomplish the objectives of this project and we were able to learn and understand how a basic DC power supply works. That is all and thank you very much for listening.